Question 10.3. For which value of h will the volume of the box be a maximum? Now remember, when we read the word maximum and minimums, we must be thinking of calculus, and in particular, the first derivative. So just like we've been doing before, we have an expression in terms of h that gives the volume of our box. So if we wanted to find the maximum or minimum of that box for which a value of h for which the box would be a maximum or minimum, you must immediately be thinking of the derivative of our expression, and then setting that derivative equal to 0, solving for h, and thus finding a value of h that will set the original expression when plugged in to a maximum or minimum, depending what they're asking. In this case, a maximum. So let's write down our expression. And now we're going to just multiply out. So 40 times 50, 2,000. If I'm correct. My arithmetic? Yes. Minus 40. H. Minus 100. H. Plus 2h squared. And then remember, all of this is times with an h. So really what we have is 2000h minus 40h squared minus 100h squared plus 2h cubed. And then we look at like terms, so that will be 2h cubed minus 140h squared plus 2000h. Fantastic. Now we're going to take the derivative of our expression. So that will be 6h squared, just normal derivative taking of single terms. 140 times 2, 280, so 100 minus 280h plus 2000. All right. So now normally what we do is we'd set this equal to 0 and we'd solve for h. But you'll notice when we do that, we are left with a quadratic with big numbers. So we can't use normal factorization here. That might be a bit difficult. But luckily for us, we have a special formula, namely the quadratic formula. Like this. So let's plug in our values and see what we get. So minus b would be 280. Plus minus, let's find the value for plus and the minus in our expression. 280 squared. Just going to leave the minus because a minus times a minus is a positive. Minus 4 and a, so that's 6 c 2000 times 2a, and that will be 12. Fantastic. Now we can use our calculator to solve this. So 280, I'm going to do the plus first, so 280 squared minus 4 times 6 times 2000 over 12. And I am left with 37.86. And I'll go to 4 decimal places, so that will be 30. And then our other answer, when it's a minus, I'm left with 8,8037. All right, so these are our two values of h. Our two values of h, where our original expression for the volume of our box will be at a maximum. So, how do we know now which one to pick? Well, remember I told you that when we find the derivative of a function that represents something and set it equal to 0, you can use that to find the maximum or minimum of that function. Because remember, if we have a normal cubic graph like this, no, let's do this. Yeah, I know that won't work. But what I'm trying to say is when we have when we find the derivative of a function and set it equal to 0, we can use that to find for what value of that variable will give the maximum or minimum of a function. But they want in particular the maximum here. So what this means is we've come out with two answers. That's because for one h the volume will be a minimum or maximum, and the other h the volume will be a minimum or maximum. So we now need to pick which h will give the maximum. Well, doesn't it make sense if this h is smaller than this h, this one has to be the minimum, and this one has to be the maximum? I hope you can see that. Not much to it, it's just a larger h with a larger volume. So then this one has to be for the value of h when the volume of the box is a minimum. So we can indicate that clearly by saying this will be our maximum. And yes, that's finished. They didn't ask us to find the value of the box the volume of the box when h is a maximum, so we don't need to plug this value back into our original function. We can just stop here because we've found the value of h, whereby the volume of the box will be a maximum. And that is the problem solved.